get started?
Okay.
Okay, so the agenda for today's session is, well, largely we're going to be focusing on causal inference, and causal inference ke andar bhi we are only covering causal directed acyclic graphs. As promised, I will go over one practice problem for the front door criterion as well. I have added a link to the notebook that we will be using on Kaggle over here to your tutorial document. You should note कि इस notebook के पास आपके two नहीं three versions available हैं. My bad. You will have three versions available. I might give you a separate version for solutions and then it's four. All right. For all graph questions, people who are watching the recording, make sure you pause, try a question out yourself, and then try to match your answer. You will benefit more from it that way. So I will give you a very quick recap of some important structures in causal directed acyclic graphs. So first we have a actually इसको हम इस side से start करते हैं. From the right, you have a chain. A chain is when you go from A to B and then B to C. So if you were about to determine the true total effect of A on C, तो आप B के ऊपर condition नहीं करेंगे because B is acting as a mediator. It mediates the causal effect between from A to C. So अगर हम B पे condition कर दें तो we will block this causal pathway which you are not supposed to block. Of course, A and C are conditionally independent given that you condition on B. We'll actually discuss D separation again as well. The next structure that you have is a fork. Fork में A and C are both the common effects of B. In this case, actually, a path exists करती है between A and C. It's a non-causal path, but the thing about this path is that B is acting as a confounder right now. For instance, if you were trying to determine the effect of smoking on cancer, A on C, so B could be age, something that affects not just the outcome but the treatment assignment as well. तो confounder के ऊपर आपको condition करना पड़ता है when you're trying to determine the true total effect of one variable on another. Because confounders are giving you spurious correlations between two variables. All right. Um, After that, the third structure that you have is a collider. A collider के अंदर A and C are common causes of B such that B is a collider. So if you were trying to determine the true total impact of A on C, so you will never condition on a collider because right now there might not be any spurious correlations between A and C. लेकिन अगर आप collider को block कर देंगे, so you might introduce, actually you will introduce a false negative correlation between the two variables A and C. I will encourage you to recall Bergson's paradox over here. It's also called collider bias. With that, let's move on. We've been over some basic structures. We're gonna look at two practice questions, causal DAGs. Okay, make sure you practice these. So this is one graph that you're given. Abhi, we haven't, even though you're given T and E, but right now we haven't decided कि इसमें कोई treatment है या कोई effect है. So let's try and identify all causal paths in this graph. I will actually just shift my screen share to the entire screen so that we can go to OneNote for this. Basit, is my screen still visible?
Yes, it's visible.
Perfect, thank you. So we will try and list all the causal paths between इसको थोड़ा सा बड़ा कर लेते हैं 14. Okay. So this I essentially forgot. All the causal paths between T and E. All right. Causal paths between T and E. I will encourage everyone to try and work these paths out themselves as well. But Basit, if you want to comment on this, तो आप मुझे बता सकते हैं. Otherwise, I will draw these paths anyway. Oh, I will quickly reiterate कि a causal path between two nodes is such a path जिसमें arrows सारे एक ही direction में जा रहे हैं, starting at the treatment and ending on the outcome. Okay, I would encourage you to try and list it yourself though. So, एक causal path हमें ये नजर आ रहा है that goes from T to D and then from D to E. And I can see another causal path in this diagram as well. The one that goes from T to B and then D and then E. There are no further causal paths between these two nodes. Because if I look at the path that follows through C, तो इसमें all the arrows are not pointing in the same direction. Next, we will try and list all the non-causal paths between T and E. Ultimately, you're left with only one path, T, and then this arrow is going into T, and that arrow goes into E. So these are all the causal and non-causal paths between T and E. Let's look at the next part of our question. Deseparation. List all the deseparated nodes in the given graph without any conditioning. इसको भी हम move कर लेते हैं for now. So now I will quickly help you guys recall कि deseparation क्या होता है? When two nodes are deseparated, essentially it means that they are directionally separated. You are not trying to determine the true effect of one node on another. Rather, you're trying to determine whether these nodes are independent of each other. Sometimes they are simply independent of each other, and sometimes they are conditionally independent of each other. In which case, you should know कि किन nodes पे condition करने की ज़रूरत है in order to make sure that those two nodes are then independent of each other. So if you have a mediator, तो आपको उसके ऊपर condition करना पड़ेगा, otherwise they are not deseparated. And if you have a collider, then they already are deseparated. अगर कोई collider वाला path है. If you have a confounder, you still have to condition on it, otherwise they're not deseparated. So to sum it up, two nodes are deseparated if either there exists no direct path between them or all direct paths between them are blocked by colliders. I will reiterate this once. Two nodes are directionally separated if either there exists no direct path or indirect path between them, or all paths between them are already blocked by colliders. So अब हम determine करते हैं. You're actually interestingly gonna have to make all combinations for this question. So I'm gonna start with T, and T को हम एक दफा सारे nodes के against देख लेते हैं. I have A, B, C, and D. That's it, right? Now I also have E. T and अच्छा, I don't have A, my bad. You have B, C, D, and E. So अगर हम T को B के against देखें तो I can just see that there exists a direct path that starts at T and ends at B. So they are not deseparated since there is a direct path. Next, let's look at C. So आपको अगर एक भी path मिल गई है तो you don't have to look at any other paths. अगर एक भी open path है between those two nodes, so they're not gonna be directionally separated. All the paths have to be blocked. Then you look at T and C. T and C are also not deseparated actually. And the reason for this is that again there is a direct path जो इस direction में जा रही है. And C. So T and C के बीच में भी एक direct path exist करती है. Let's look at D. Well, for the very same reason, ये भी deseparated नहीं है. Because a path starts at T and it ends at D. So I have one last node to check against T, and that is E. T and E are not deseparated either because, well, I can see a path that goes, well, it's not a direct path, but एक path हमें ये मिल गई है, the one that goes from T to D and then D to E. Hence, there is no node जो T के साथ deseparated है. But then, of course, since you have to list all the deseparated nodes in the graph, you're gonna have to check all the other combinations as well. So I've already checked for T. Why don't I check for D next? अब मैं इसको T के against नहीं check करूंगी because I have essentially already done that over here. I will check it against D. So C, D, and E. Against C, it is not deseparated because we have found a path over here. And the path is, well, it starts at C, then it goes to T, and then it goes to B. So to quickly highlight, I am talking about this particular path. ये direct path जा रही है between them. As long as I found one, I don't have to check the rest. Then I can check B with D. They are also not deseparated because, well, very clearly you can see a direct path that is going from B to D. Lastly, for B, you're going to check it against E, and they are also not deseparated because while you may not have a direct path between them, but एक path जा रही है that starts at B, then it goes to D, and then it goes to E. Now that I have checked for both T and B, so I will obviously need to check against C. So against C, I only need to check D and I need to check E. And C and D के बीच में I can clearly see this particular direct path. So they're not going to be deseparated. Even though there's another path between them as well, ये path collider से blocked है, but since मुझे एक open path मिल गई, तो I don't care about the rest. So not deseparated since there is a path that, okay, T, D, and then, okay, D. What about D and E? Again, not deseparated because I can clearly see a direct path between them. It starts at D, it ends at E, which means that I have to check. I only have to check D now. Yeah, technically I only have to check D. And D को भी मैंने सिर्फ अब E के against check करना है. And D and E are not deseparated because I can see a direct path that starts at D and it ends at E. I have tried every single combination of nodes, and now I can conclude that there are no nodes in this graph that are deseparated without any conditioning. अभी हमने condition नहीं किया. So let's move on to the next part of this question. Now, if you condition on the node T, then let's try and list all the paths in this given graph again. हम इस नोड को हाईलाइट कर देते हैं जिसके ऊपर हमने कंडीशन किया हुआ है. T conditioning means that you have fixed the value of T, which means that T के against I can no longer check any node. I will check against B, C, D, and E. And I will not check any of these against T either, since T को हमने block कर दिया हुआ है already. So let's try that out. I will check B against C. They are still not deseparated because very clearly this path still remains open. Then I can check B against. Oh, extremely my bad. I was checking B against D. B and D will not be deseparated. Like, and I have to check B against C as well. So let's try and list all the paths between B and C. पहली एक ये वाली path है which exists between them. इस path के अंदर E is a collider and जिस path में collider exist करता है वो path already blocked होती है. Let's try and draw a different path between them. I also have this path between them where T was acting as a mediator. लेकिन T पे मैंने condition कर दिया, so I have blocked this path as well. Lastly, I have this particular path available. Is path में D is a collider and you've already conditioned on T as well. So this path is also blocked. What essentially happened was कि मुझे कोई भी open path नहीं मिली between B and C, which means that B and C I can say are D-separated. Let's look further. B and D we have already established are not D-separated. B and E are also not D-separated because ये path भी open है still. Then I look at C and D. Let's think about this one. There is this path between C and D, which is blocked since E is a collider in this path. There is this path between C and D, which is blocked because you've conditioned on T. And lastly, there is this path between them, which is also blocked since we've conditioned on T. So that means K, C and D are D-separated. Since there is no path between them, that still remains open. What about C and E? Acha, C and E are not D-separated. They cannot be D-separated because directly एक path उनके बीच में exist करती है. What about D and E? Yeah, D and E cannot be D-separated. Either there exists a direct path between them. So हमारा जो final answer होगा, जिसमें we are listing all the nodes that are D-separated, conditioned on T, that will be B and C and C and D. So ये दो pairs बनते हैं of D-separated nodes. Are there any questions up until this point? Okay, we've covered causal paths, non-causal paths, D-separation, conditional D-separation, and now we are gonna look at conditioning. Oh my god, I was just supposed to copy this. So इसको भी हम एक example के through देख लेते हैं. So the question is, what variables should we condition on in order to determine, अब इसको हम erase कर देते हैं actually. What variables should we condition on in order to find the true total effect of T on E? So T का effect आपने find करना है on E. And you want to determine which variables to condition on. So I will quickly help you recall. Okay, you do not condition on a mediator because you block causal associations that way. You always condition on a confounder unless the backdoor path is already blocked, because a confounder otherwise transmits non-causal spurious correlations between two variables, and you do not condition on a collider. Collider wali paths are blocked. If you condition on a collider, तो एक negative spurious correlation establish हो जाता है as per the Bergson's paradox. Anyway, so what essentially you do is कि you list all the backdoor paths between the two variables. And the interesting thing is कि हमने सारी causal paths भी list कर ली हुई थी between T and D, and सारी non-causal paths भी list कर ली हुई थी between T and D. And there's only one non-causal path between them. So I will quickly reiterate कि backdoor path क्या होती है, because this is very important. So I'm listing all the backdoor paths between these two nodes. Can I say that all non-causal paths are backdoor paths? That's not true. A backdoor path is such a path जिस path के शुरू में भी arrow treatment variable के अंदर जा रहा होता है, and then the arrow at the end is going into your outcome variable. Whenever you have backdoor paths, it means that there is a confounder somewhere along that path. And the next question is, do you always have to condition on a variable in a backdoor path? That's not true. आप सारी backdoor paths list करते हैं between two nodes. जो backdoor paths already blocked हैं, you leave them as it is. जो backdoor paths नहीं blocked by default, उसके अंदर you have to condition on something. In nodes के बीच में there is only one backdoor path, and there is C, which is acting as a confounder. in that path, so you will have to condition on C. जब हमने C पे condition कर लिया तो हमें किसी और node पे condition करने की जरूरत नहीं है. So that is your solution. Okay, let's move on to our next question then. Just a quick second. I thought we could maybe just reuse this to save our time. Okay, perfect. So I have another graph over here, a slightly more complex graph with a few more. इसको highlight करना नहीं था. Never mind. Okay, so let's look at this particular graph. And then let's look at our first question. Identify all causal and non-causal paths from X to Y. So इसको हम दोबारा से लिख लेते हैं between X and Y. Again, this is the point where I will encourage you guys to pause and state these paths yourself as well. Not sure if we have anyone else here still, but would someone like to propose a path over here? Okay, I'm gonna draw out a path then. Very clearly, I can see this path between X and Y. That's not a causal path. हम पहले causal paths list कर लेते हैं. Interesting. There are no paths between X and Y that are causal in nature. Let's recall कि causal paths के अंदर all the arrows are headed in one direction. But non-causal paths exist करती हैं for sure. So I have X, A, and Y. That's one of our non-causal paths. I have another X, B, C, and Y. Do I have a third? No, I only have two non-causal paths between these, and I have zero causal paths between them. So let's try and list all the d-separated nodes in the graph without any conditioning. Okay, perhaps let's start with X. And X के लिए we're gonna have to check A, B, C, D, and Y. X and A are not d-separated. I'm not gonna go into further depth of every single node. I'm not gonna write it all down. We're gonna quickly go over it, so you guys should try that out yourself as well. X and A are not d-separated because ये direct path exist करती है between them. X and B are not d-separated because a direct path exists between them. X and D are also not d-separated because a direct, well, not a direct, but a causal path exists between them over here. So मैं इसमें से options eliminate कर देती हूँ अब. Not A, not B, certainly not D. What about C and Y? So X and C के बीच में there is a path over here which is blocked because B is a collider in this path. Then there's another path between X and C over here, which is also blocked because Y is a collider over here. There are no further paths between X and C. So this means that they are d-separated. Similarly, if I check X and Y, तो X and Y के बीच में मैंने सारी paths यहाँ पे list कर ली थी. And this path between them is essentially open. Because इस path के अंदर A is a confounder, not a collider. Collider वाली paths by default blocked होती हैं. Which means that X and Y, sorry, are not d-separated either. With that, let's move on. And why don't we try for A? So A के लिए I have already checked X, which means that I can check B, C, D, and Y. Again, I'm gonna make this quick. ए एंड वाई के बीच में डायरेक्ट पाथ एग्जिस्ट करती है, दे कैन नॉट बी डी-सेपरेटेड. Then I have A and C. Interesting. A and C के बीच में this is the first path where Y is acting as a collider. So this path is already blocked. This is the only other path between A and C, which is also blocked because B is a collider. So A and C are in fact, इसमें से I'm only removing Y right now, by the way. A and B are de-separated. Next I have, oh, I've checked for A and C, not A and B. My bad. ठीक है, हम A and B को भी check कर लेते हैं. A and B के बीच में I have this direct path. Well, not direct path. I have this path that where X is acting as a mediator. So they cannot be de-separated either. Next you have A and D. A and D के बीच में भी there exists this particular path, causal path, which is why they are also not de-separated. So I suppose we can move on and check for B. I will not check it against A and X. I will check it against C, D, and Y. Okay, so let's check B and C. There's a direct path over here. They're not de-separated. B and D के बीच में भी there's a direct path. They are not de-separated. So I will get rid of C and D and let's quickly check for Y. B and Y के बीच में there's a path over here as well, which may be a backdoor path. Well, it is a backdoor path, but the backdoor path is not blocked though. C is a confounder. This path is open, so they cannot be de-separated. Next, we have C. I will not check it against X, A, and B. I will check it against D and Y. So C and Y के बीच में there is a path where B is a mediator, and C and Y के बीच में there is a direct path over here. So C is not de-separated with any further nodes. Next, I will check D. Actually, lastly, I will check D. And D, I only have to check against Y technically, because I've already checked it against all of those above. So D and Y cannot be de-separated since ये path exist करती है where C is just a confounder. So when you are listing all the de-separated nodes, these are the pairs that you will list. X and C and A and C. ये वो nodes हैं जो by default de-separated हैं. Now, let's try and list all the de-separated nodes if you condition on B. No, condition on B. So B को हम block कर देते हैं. We are gonna block B over here. We're fixing the value of B. So students will make one common mistake over here. जो already nodes listed हैं as de-separated without any conditioning, they will just check to see if any further nodes are de-separated other than those. But it is possible कि जो already de-separated थे, they may not be de-separated any longer. If I'm not wrong, we will view this in this particular example as well. So अभी हमने नीचे note किया हुआ है those nodes which were de-separated without any conditioning. So let's begin with X again. X and A still a direct path. X and B के लिए तो obviously we can't check any longer. Then X and C, this is interesting. Pहले I'm removing A as well. Okay. So the thing is कि X and C के बीच में this path existed where B was acting as a collider. As soon as we conditioned on B, we opened up this path. But there is another path between X and C where Y is a collider and that path is still blocked. However, since एक path आपके पास open हो गई है and like we discussed, as long as there is even a single open path between two nodes, they cannot be de-separated. So ये जो nodes already deseparated थे X and C, they shall no longer be deseparated. I hope that makes sense. Next you have X and D. X and D के बीच में, this was one path where B was, well, it was a mediator. Now you blocked B, तो आपने ये path block कर दिया. The other path was also passing through B. So essentially now all paths are blocked between X and D. They are going to be de-separated now. What about X and Y? X and Y के बीच में there still exists a path that passes through A, so they're not de-separated. I can try for A. A के लिए you have, well, not X, but B, C. Oh, not B either, since B
I
is
have
there.
question.
Yeah,
X and C जो हैं ये डिसेपरेटेड है.
X and D. Yeah, yeah, absolutely. ये देखें, X
X
and
and
D
C,
are
X and C,
de-separated after we have conditioned on B.
X and C basically.
X and C, अच्छा हम इसको फिर से रिविजिट कर लेते हैं. X and C के बीच में ये वाली पाथ थी which was blocked previously, लेकिन जब हमने B पे कंडीशन किया तो ये पाथ ओपन हो गई. So X and C are not deseparated now. पहले ये थे deseparated. Does that make sense?
ओके ओके ओके.
You know,
ठीक
B is a collider. अगर आप collider पे कंडीशन करें तो आप पाथ ओपन कर देते हैं.
ठीक है ठीक है ठीक है, समझ आ गई.
Okay, so अब हम C D Y के अगेंस्ट A को देख लेते हैं. A का Y के साथ एक direct path है over here, and well, let's check A and C. ये path है where C is a collider, so ये path तो blocked है. दूसरा सिर्फ ये वाला path exist करता है where B was a collider. अब ये path open हो चुका है. Since you have conditioned on B, so you have opened up this path, which means that A and C cannot be deseparated. Lastly, let's look at A and D. A and D के बीच में, this was one of your paths which you have blocked, and the other path was this one, which was already blocked since Y was a collider. So A and D are in fact deseparated. Next, I can check for, well, I can't check for B, so I'll just check for C. Not against X or A, but D and Y only. So C and D को हम देख लेते हैं. C and D के बीच में, this was a path which has been blocked. This was the other path which is blocked by default because of Y. बेशक आपने B पे भी condition कर लिया. So these are deseparated. What about C and Y? C and Y के बीच में there exists a direct path. So I will check D now. And D के against I've checked everything except for Y. So ये वाला path था which is blocked because of B, and then this was the other path which is also blocked because of B. So these are also deseparated. Let's see, I have X and D, I have A and D, C and D, interesting, and D and Y. Are there any questions up until this point? Okay, we shall move on then. So causal graphs के लिए for now, this is gonna be the very last question. What variables should we condition on in order to observe the true total effect of X on Y? Let's see. X on Y. Let's again recall quickly कि mediator के ऊपर आप condition नहीं करते, fork के ऊपर आप condition करते हैं, and collider के ऊपर भी आप condition नहीं करते. So between X and Y, we have already listed all the causal and non-causal paths. And जितनी भी paths हैं, in total, वो सिर्फ यही बनती हैं. So what you do is, you list all the backdoor paths between two nodes. And once again, I will reiterate कि a backdoor path is a path जिसके start में the arrow is going into the treatment and end में the arrow is going into the outcome. So the first path is certainly a backdoor path, but is the second path also a backdoor path? No, it is not, because ये वाला arrow जो start वाला है वो treatment के अंदर नहीं जा रहा, which means you only have one backdoor path. Is this backdoor path blocked? It is not. So in order to block it, you have to condition on A, which means that without conditioning on A, you cannot determine the true total effect of X on Y. Are there any questions up until this point?
आई एम सो सॉरी, लेकिन ये वाला पार्ट दोबारा रिपीट कर सकती हैं?
No problem at all. No worries whatsoever. Yes, we will go over it again. So आपने true total effect determine करना है x का y के ऊपर. जब आपने किसी node का true effect determine करना हो on the other node and you're trying to figure out what to condition on, the first step is कि you list all the backdoor paths between those two nodes. और सिर्फ यही एक बैकडोर पाथ एग्जिस्ट करती है बिटवीन देम. लेट्स रिकॉल के बैकडोर पाथ वो पाथ होती है जिसके स्टार्ट में एरो स्टार्टिंग नोड के अंदर जा रहा है एंड लास्ट एरो एंडिंग नोड के अंदर जा रहा है. So an arrow goes into the treatment and an arrow goes into the outcome. फिर आप चेक करते हैं उन बैकडोर पाथ्स को वन बाय वन टू सी इफ दे आर ब्लॉक्ड और नॉट. जो बैकडोर पाथ्स नहीं ब्लॉक्ड होती उनमें यू हैव टू कंडीशन ऑन ए सर्टेन नोड इन ऑर्डर टू ब्लॉक देम. सिंस ये एक ही सिर्फ पाथ थी एंड इसमें ये पाथ ओपन है. पाथ ब्लॉक तब होती है जब उसमें कोलाइडर प्रेजेंट हो. ये पाथ ओपन है, सो यू हैव टू कंडीशन ऑन ए. डज दैट मेक सेंस?
यस, और इस केस में अगर एरोज दोनों ए की तरफ आ रहे होते, फॉर इंस्टेंस एक्स टू ए एंड वाई टू ए, तो हम ए पे कंडीशन करते होते हैं.
या एब्सोल्युटली.
ओके, परफेक्ट, थैंक यू.
नहीं, आई मीन होल्ड ऑन, कुड यू रिपीट दैट? आई
के
थिंक आपने यही मेंशन किया जो लिस्टेड है पाथ ऑलरेडी. एक्स में एरो आ रहा है एंड वाई में एरो आ रहा है.
ओ, बल्कि वो बैकडोर पाथ ही ना होता, राइट, सही.
या एग्जैक्टली. अगर आपके पास कोई इस नेचर की बैकडोर पाथ होती, मैं आई डोंट वांट इट टू बी स्पेसिफिक टू दिस नोड, बट ये देखिए द एरो इज गोइंग इनटू पी एंड सपोज के आउटकम आपका ओ है, तो फाइनल एरो भी ओ के अंदर जा रहा है. एंड देन इन बिटवीन यू हैव क्यू आर एस टी. इसको वी कह देते हैं इनफैक्ट. तो दिस इज अ बैकडोर पाथ. माय क्वेश्चन इज कि इज दिस बैकडोर पाथ ओपन या इज इट ऑलरेडी
नो,
ब्लॉक्ड?
इट्स ब्लॉक्ड बाय आर, तो आर पे कंडीशन
एक्सीलेंट.
करेंगे.
नहीं, you were half right. It's already blocked by R. तो जो बैकडोर पाथ ऑलरेडी ब्लॉक्ड होती है उसमें आपको किसी भी नोड पे कंडीशन करने की जरूरत नहीं होती.
अच्छा, तो जो ब्लॉक्ड होती है उस पे कंडीशन नहीं करते, जो ओपन होती है उस पे कंडीशन करते हैं.
यस एब्सोल्युटली.
ओके,
आप
ओके,
सारी बैकडोर पाथ्स लिस्ट करते हैं. जो बैकडोर पाथ्स ऑलरेडी ब्लॉक्ड है बाय डिफॉल्ट, यू लीव देम. जो
ओके,
बैकडोर पाथ्स ओपन है उनमें आपको कंडीशन करना पड़ता है किसी नोड पे इन ऑर्डर टू ब्लॉक देम.
ठीक है, परफेक्ट, थैंक यू.
नो वरीज. Are there any other questions actually
नो,
before we move on?
नो, थैंक यू.
Okay. I'm still adding a third version to this notebook. There was a Kaggle issue. I sure hope it works now. We're gonna go over an example of the front door criterion. Just give me a few seconds. Okay, yeah, so हम front door criterion की एक example देखेंगे and we will look at it in depth. We've already looked at the formulation in class, but since this is fairly daunting to begin with, I will do a 5-minute recap. So, this is one particular example, a hypothetical causal diagram for smoking and cancer. This diagram is suitable for front door adjustment. And first, I will tell you guys कि आप front door adjustment करते कब हैं. So, you're trying to determine the true total effect of smoking on cancer. So, again, pause over here for a few seconds and think about what nodes you need to condition on in order to do so. लेट्स रिकॉल कि आप सारी बैकडोर पाथ्स लिस्ट करते हैं. जो बैकडोर पाथ्स ओपन है उनमें आप कंफाउंडर्स पे कंडीशन करते हैं.
इस केस में स्मोकिंग गेन, स्मोकिंग जीन.
या परफेक्ट, स्मोकिंग जीन के ऊपर आप कंडीशन करेंगे। एंड कंडीशनिंग मीन्स कि आप उस नोड की सारी पॉसिबल वैल्यूज को फिक्स कर देते हैं। द प्रॉब्लम इज दो कि स्मोकिंग जीन की वैल्यूज कैन नॉट प्रैक्टिकली बी मेजर्ड और फिक्स्ड बाय दैट, फॉर दैट मैटर। जब आपके पास इस तरह का केस हो, व्हेन कंडीशनिंग ऑन ए कंफाउंडर इज नॉट पॉसिबल, इसका मतलब है बैकडोर पाथ नहीं ब्लॉक की जा सकती, तो देन यू ट्राई योर फ्रंट डोर क्राइटेरियन। there are certain assumptions that need to hold true for the front door criterion. आप इसमें mediator को use करते हैं. Your mediator is tar. Mediator is something that's part of a chain. You know, smoking goes to tar, tar causes cancer. So you will try to use tar to estimate the average causal effect of smoking on cancer. Since आप smoking gene पे condition नहीं कर सकते, I will not go over the assumptions again. We've gone over each assumption and the reason why each assumption is necessary. But however, I will go over the formulation again once. So मैंने उसी diagram को लिया है और इस form में transfer कर लिया है to make things simpler for us. Before we look at the formulation, let's see what we have over here. X is the treatment, in this case smoking. Y is the outcome, in this case cancer. So हम X का Y पे, smoking का cancer पे effect measure करने की कोशिश कर रहे हैं. Z is your mediator, in this case Z is star, and then U means uncontrolled confounding variables. या unobservable होते हैं या uncontrolled होते हैं, whatever it is. In this case, the smoking gene is U. Anything else can go into U as well, by the way. We have a formulation. इस formulation में eventually just this very last thing जो आपको given है, because you know this is what you're trying to find ultimately. In order to find the true treatment effect of X on Y, this is what you need to find. The probability of Y given that you intervene on X. You want to see कि अगर X की smoking की value को intentionally fix किया जाए तो उसका क्या impact होगा cancer के ऊपर. And this is the formulation. This is the final formula, sorry, for the front door criterion. Summation Z, and then uske andar you have another summation for X, and well, this entire thing. But I will quickly tell you how you get there. First, you compute probability of Z given that you intervene on X. Z and X. The thing is though कि Z and X के बीच में there is no confounding variable right now. This is one of the assumptions of the front door criterion. अगर इनके बीच में कोई confounding variable होता, तो we wouldn't have been able to apply this front door criterion. Anyway, since इनके बीच में कोई भी confounding variable नहीं है, तो I can say that the probability of Z given do X equals simply the probability of Z given X. This thing is only true जब कोई confounders नहीं होते, as we've covered in lecture 12. This is the first thing that you need to compute. And we will try to compute this using our data as well. Next, you have to compute probability Y do Z. So, जब हम Y and Z को देखते हैं, you know, first I try to measure the effect of X on Z, मतलब smoking on tar, and then I try to measure the effect of Z on Y, which means the effect of tar on cancer. So, Z and Y के बीच में there does exist a backdoor path. जो backdoor path ये वाली है, X goes to Z, then ये U है, and then Y. So you know an arrow goes into the treatment and it goes into the outcome. If I quickly draw this path out, so this is what it looks like. ZX U Y. See, that's a backdoor path. इस backdoor path में जो confounder है वो U है, but U को हम control नहीं कर सकते. So अगर हम X को control कर लें, तो भी we are blocking this path. Which is why when you compute probability Y given do Z, so you are controlling for X over here. See, this formulation was studied in, I believe, lecture 11 or 12. So आप x की एक एक वैल्यू के लिए इसको फिक्स करेंगे. We've done an example of this in tutorial 6 as well. And that is how you will find the probability y do z. जब ये दोनों probabilities आपके पास आ गई हैं, So this is where I will plug them in. Let's look at the third step. This is the front door criterion. Probability y do x equals summation z probability y do z into probability z do x. So अब मैं जो दोनों चीजें multiply कर रही हूँ actually ऊपर I have already expanded them. So in the last step, I just perform a simple substitution. I will pause over here and give you guys a few seconds to go through this actually. And then we will look at an example hands-on. Okay, are there any questions? If this is not clear to you still, it certainly will be a lot more clearer to you after we solve this example. So to make things simple, we are using the exact same example using numbers जो अभी हमने ऊपर discuss किया. So, a study of 800 people records whether each person is a smoker, X, or non-smoker. So, X exactly यही था, whether a person smokes or they don't. Whether they have tar in their lungs, which is denoted by Z, and whether they have cancer, which is denoted by Y. You will note कि हमने U के against कोई भी values नहीं लिखी यहाँ पे because U we cannot observe right now. And then we have a table over here जिसमें आपको ये सारे observed counts given हैं. इस table को use करके हम probabilities compute करेंगे. So let's see. अगर हम सिर्फ total देखें, at the very end you will see that in total you have 400 smokers and you have 400 non-smokers. Similarly, in total you have 380 smokers um, who have tar in their lungs and 20 non-smokers who have tar in their lungs. You have 20 smokers who have अच्छा ये exactly वही चीज है. Anyway, I'm not gonna go over every single stat. इसमें से एक value pick करके at least उसको interpret कर लेते हैं. This particular number 18, what does 18 represent? 18 represents the number of smokers with no tar in their lungs that had no cancer. So you should just know how to interpret it that way. With that, let's move on. Use the front door adjustment to estimate probability that y equals cancer given do x equals smoker. So essentially ये exactly वही चीज है probability y do x. Except कि x की value को अब हम smoker के ऊपर fix करके देख रहे हैं. But that's all a matter of math. This is a multiple step process. And well, let's get started. This is the first thing that you will compute. मैं इसको copy करके नीचे लेके आ रही हूँ to make things slightly simpler. For now, let's get rid of this. So सबसे पहले हम ये वाली चीज compute करेंगे. Probability z do x. I know that z is star and I know that, let me write this down. So I know that z is star and I know that x is smoking. Equals probability z, this is fairly simpler. This is fairly simple. Given x, this is what we're trying to find. Let's compute a few simple probabilities, which we will use in our math. What is the probability that x equals smoker? Okay, of course, we will be needing this. Similarly, let's compute the probability that x equals non-smoker. So smoker ke liye I have, oh, that's actually pretty simple. See, I have 400 smokers and I have 400 non-smokers. So 400 divided by 800 each, which means ke 0.5 each. ये मैंने initial दो stats compute कर लिए. The probability that an individual is a smoker is 50% and the probability that an individual is a non-smoker is also 50%. Next, why don't I compute? Actually, since मैंने ये वाली चीज find कर ली है, तो हम इसी पे आ जाते हैं. Probability z equals अब हम इंडिविजुअल वैल्यूज के लिए देखेंगे z equals star given that x equals smoker, for instance. Similarly, we can find the probability that z equals star given x equals non-smoker. And similarly, हम दो और values भी compute कर लेंगे. I will show you guys where we will use these. X equals no tar. So probability z equals no tar, my bad, and x equals smoker. इसको थोड़ा सा I'm spacing it out because it's getting a little bit cluttered. There we go. So let's compute each of these probabilities. I would encourage you to pause and try these out yourself as well. And for those of you live, इसको आप immediately भी try करके देखें. We will compute these values and we will add them. So probability z equals star given x equals smoker. Let's see. I have 300 and yeah, ये मेरे पास star वाला group है. I have 400 people in total in my tar group, and I have 380 people in my tar group that were smokers. So this is fairly simple. 380 people who were smokers and 400 people जो ये 380 plus 20 total tar वाले group में थे. What does this give me? This gives me 0.95. Next, I can find the probability of tar in non-smokers. And that's fairly simple क्योंकि ये 20 over 400 हो जाएगा. You know, just 1 minus the one above, which is 0.05. Similarly, हम ये अगले वाले डेटा के ऊपर आ जाते हैं. Note R के ऊपर. So Z equals note R and X equals smoker. So there are 20 smokers out of 400 who do not have tar. 20 smokers थे, 400 individuals के पास there was no tar. So this will be equal to 20 over 400. ये numbers ही थोड़े symmetric हैं for this particular example. And then here, of course, we'll have the remaining of this, which is 380, which is again 0.95. So up until now, I believe that we are done. हम next step पे आ जाते हैं. I will overwrite this. You know, I have all the values that I needed above. सारी substitution मैं final front door criterion की formulation में ही करूँगी. This is what I want to do now. The probability y do z for which I have to condition on x actually. And x was what? X was whether people are smokers or not. So let's focus on this formulation. Probability y given z comma x multiplied by the probability of x, and then you sum these up for every single value of x. So let me show you what that means. इसको expand करके लिख लेते हैं and then let's compute it. Y equals, well, cancer. मैं इसको initially cancer के लिए देख लेती हूँ. Actually, I only need this data for cancer, my bad. Tar के लिए you needed it for tar and no tar. So probability y equals cancer given, look, y and then given z comma x. तो मैंने z की भी हर वैल्यू को देखना है and मैंने x की भी हर वैल्यू को देखना है. Z equals star, x equals smoker. This is not the only thing that I have to find. मुझे इसको multiply करना है फिर with the probability of x, which means the probability that x equals smoker. But अभी हम इनकी simple values सारी compute कर लेते हैं. This would be no tar. This would be no tar again. This would be non-smoker. And this would be non-smoker. So अभी ये सारी essential values हम calculate कर रहे हैं. When we estimate these, for one particular instance, so we will keep multiplying these with the probability of X in the general population based on our data as well. For now, let's compute these values. Actually, this is also fairly simple. If we go back to our table, just gonna copy these here. Let's see. Probability y equals cancer. So हम cancer वाली रो में चले जाते हैं. This is the cancer row. Y equals cancer given that z equals no tar. सॉरी z इक्वल स्टार पहले टार है सो हम इन दोनों पे नैरो डाउन कर लेंगे 57 एंड 19 एंड x इक्वल स्मोकर सो ये नंबर 57 एग्जैक्टली आता है हमारे पास which means 57 will go in my numerator and since I am checking against those people only that do have cancer तो ये मेरे पास टोटल कितने लोग हैं let's see. Given that x equals smoker, yeah, I have 380 over here. So I will divide this by 380, which will give me 0.15. Does this step make sense? Are there any questions? Okay, moving on. Then I have z equals no tar and x equals smoker. इसके लिए what row am I going into? No tar. So I'm just going here automatically. This is the number that I'm looking for, 2. And since smokers is category में 20 थे, तो my answer is actually gonna be 2 over 20, which is 0.10. Next, I have y equals cancer given z equals tar, comma x equals non-smoker. So tar के अंदर non-smokers में I'm going here 19 divided by 20, which is equal to 0.95. Lastly, no tar, non-smoker. So ये वाला number 342 divided by 380, which is equal to 90%. So I'm gonna move these values down here as well. इसके ऊपर हम लिख भी देते हैं कि what we are trying to determine at this step. What part of the computation are we on? Do Z. Okay, moving on. Next, let's try and why don't I just add this part over here now? Oh, sorry, we're right over here. अब हम front door criterion apply करेंगे, which is just a matter of plugging in values at this point, since we've already computed most of what we needed anyway. This is where I will plug in all my values. And this is one of our most essential steps as well. So, pehle I have to do it for this particular thing. Y cancer do x equals smoker. This is what I'm computing exactly ऊपर वाली formulation के against. And I will use the numbers that I have figured out up until this point. So first of all, I will do अच्छा I can't write sigma that way unfortunately तो मैं इसको sum लिख रही हूँ या इसको summation लिख देते हैं to make it a little bit more clearer. I have the probability of y and इस case में y equals cancer. Of course we're only checking for cancer. I don't need to write that down. Given that z equals star comma x equals, should I specify an x right now? अच्छा, so interestingly for this particular example, since X smokers को represent कर रहा है and both smokers and non-smokers are exactly 50%, so I will just count it as 50%. Let's check this against smoker intuitively and then we will multiply it with the probability that x equals so yeah, actually that's my bad. इसको it's fairly hard to write it down over here. हम x bar से represent कर देते हैं क्योंकि this is the part of the formulation that I'm focusing on right now. We'll just add it over here. This thing जहाँ पे I have to consider every single value of x. एक certain extent तक हम इसको देख चुके हैं already. ये मैंने ऊपर वाले से ही extract किया है. So I will have to check this for each given value of x bar. मतलब first I will check it for simple smokers, then I will check it for non-smokers, then I will add whatever values I obtain. ठीक है, let's compute this sum and let's see what this gives us. So essentially, I'm gonna expand on this for our information. The probability of y given z equals star, comma, x equals smoker multiplied by the probability that x equals smoker. If you guys recall, so summation में हम exactly यही कर रहे हैं. ये ऊपर वाला formula which I've copied down. I have to check this for all possible values of x. And I'm doing this only when tar is true. Plus, and then I will do this for non-smokers as well, multiplied by the probability that x equals non-smoker. So it's just a matter of plugging in values and computing this sum now. इसको हम ट्राई करके देख लेते हैं. इसमें से हमने कुछ कंप्यूट किया भी हुआ है एक्चुअली. Probability of cancer given that z equals star and y equal and x equals smoker. So let's see. Look, ये exactly ये वाली चीज है which we found out to be 0.15. So 0.15 multiplied by the probability that x equals smoker, and we know कि x equals smoker की probability and non-smoker दोनों की 50-50% थी, plus probability y given z equals star, comma x equals non-smoker. ये भी हम find कर चुके हैं. This is what I was looking for. This was 0.95 multiplied by, again, the probability of non-smokers is 0.5. So I will compute this is equal to 0.075 plus 0.475, which is equal to 0.55. ये अभी हमने सिर्फ inner sum calculate किया है, to be very clear about this. Next, you're gonna have to do the same thing for notar, the exact same thing for the notar group as well, because अब अगर आप देखें तो eventually you have an outer sum as well. Outer sum में you are checking all values of z, and z means star. So we will plug these in later. अब हम इसको check कर लेते हैं. Tar के against you will just check no tar. Nothing else changes. Everything else remains the same. All of our values have still been computed above, so this shouldn't be very hard for us. Smoker and non-smoker की probabilities अभी भी 50% ही रहेंगी, so I'm leaving them there. Probability of cancer given z equals no tar and x equals smoker. This thing, 0.10. Then the probability of cancer given z equals no tar and x equals non-smoker. No tar, non-smoker, this is it, 90%. And this will give you 0.05 plus 0.45, which is equal to 0.50. So हमने inner वाला sum calculate कर लिया है for both individual values of z. Look at what you are multiplying it with as well though in your final formulation. I will get rid of this and I will reiterate कि ये वाली चीज हमने compute कर लिया for all values of z, but when you plug it in, so you have to multiply it with this thing as well, which we have also computed over here. Now we will be using those values. So let's move a step ahead. Are there any questions up until this point? Okay, all right. So this is our very final step. अब हमने ये final summation सिर्फ apply करना है. So I will do the probability of y, which is obviously y equals cancer, given x equals smoker, given do x equals smoker. So अब हम ये final sum compute करेंगे, which is equal to, well, over here I have 0.55 plus 0.50. I will just quickly tell you कि अभी मैंने क्या किया है. मैंने ऊपर जो दो values compute की थी, ये वाली 0.55 and 50. Since I have to do a summation, I have just written both of them down over here. So let's reiterate कि summation में और क्या चीज included है, which is multiplied by them. Probability z given x, we have to do this as well. So ऊपर वाले केस में जहाँ हमने 5 calculate किया था, वहाँ what is x given to us as? You have, okay, let's see. This is the value that you're looking for, because right now you are intervening and checking when x equals smoker. So you have z equals tar and x equals smoker, क्योंकि इस instance में हम tar के against check कर रहे थे. So your value is 0.95. I will plug in 0.95 over here. In this case, you have the exact same thing but with no tar. So smoker and no tar. This is what we have over here, 0.05. इससे हम multiply करेंगे, which will give you 0.5225, okay, and 0.25, which is 0.5475. Very interesting. इसको हम copy कर लेते हैं. This is our final solution over here. Now, what if I want to do the exact same thing but for non-smokers instead? I will encourage everyone to pause over here and to definitely try this out on their own as well. So interestingly, जो चीज मैंने ऊपर compute की है, वो चीज as it is use हो जाएगी आपके लिए. Just these two things, because it's this particular inner part of the summation, जो inner sum है, we can use this as it is. Just that whatever I'm using on the outside now has to be specific to a non-smoker. So this is fairly simple. Okay, I'm gonna go ahead and add the solution to this over here now. ये वाली दो values आपके पास change हो जाएंगी. You just have to figure out what value goes where now, because these two will remain exactly the same. The inner sum does not change. So now, where I was considering tar and smoker and tar and non-smoker, अब I will have to consider no tar in both of these categories. So no tar and smoker पहले multiply होगा, which is 0.05, and then this one, which is 0.95. And this will give you 0.0275 plus 0.475, which is equal to 0.5025. Wonderful. This is what we have been able to do. Now, if I want to estimate the causal effect, so I will just take the difference of these two values, which is equal to 0.5475 minus 0.5025, and my answer comes out to be 0.4 something, 0.045. ठीक है, which is like when you check it in percentage, तो ये 4.5 percentage points बनते हैं. One last part to this question, because this is very important. compare the result to the naive observational. अभी हम observational calculate कर रहे हैं, ऊपर हमने interventional calculate किया है by using the front door criterion. So this is what you are finding. The probability that y equals cancer given x equals smoker. इसको तो डेटा से डायरेक्टली देखा जा सकता है. You will just check the total cancer amongst smokers divided by the total smokers. So total smokers हमारे पास कहाँ से आएंगे? 380 यहाँ पे smokers हैं and 20 यहाँ पे smokers हैं. So you have 400 smokers in total. How many of these have cancer? 57 plus 2. 57 plus 2, which is 59. So this will be 59 divided by 400, which is a very small percentage. 14.75%. This is interesting. From our observational conditional probability, you see that amongst people who have cancer, only 14.75% happen to be smokers, which intuitively tells you that maybe smoking is not really linked to cancer a lot. Lekin upar when we calculate the average treatment effect, so we realize that this is fairly high actually, 4.5 percentage points. That will be all as far as the front door criterion is concerned. Are there any questions at this point? Okay, that will be all from my side. I will encourage you all to try and solve this example by hand yourself as well. All right, good luck with exam 2. Allah Hafiz.